Okay, girls, we're going to listen. So, here we go. Today's date, 5/21/18. Okay? So, we're going to talk about geometric series and sequence. One more time, a series is just a list of numbers. That's all a series is. It's just listing them out. A sequence is where you backwards. A sequence is a list of numbers, and a series where you add them all up. Okay, so this is a sequence. Okay, now if we want to find the 15th term, we need our formula. Of course, luckily for you, we have them on the board, and it's right there. Okay, so R is called the ratio. R is the ratio, or it's the multiplier. Okay, so the multiplier. What are we multiplying by? So in this case, seems like we're multiplying by -2 because it goes negative, positive, positive, negative. So what I can do is R is definitely equal to -2. Now, if you're not sure how to figure out R, if you absolutely know it is geometric, R can be found by taking A2 divided by A1. Take the second term divided by the first term, and you'll always get R. If you know it's geometric, because you know that 10 divided by -5, sure enough, that's -2. But you can see it's -2, can't you? So if you're not sure what the multiplier is, you can always divide the second one by the first one to get it. Okay, so let's use our formula. A of 15. So 15th term, we'll go A of 15. Because we want to find the 15th term. A of 15 would be the 15th term. Is equal to A1, which we know is -5, times R, and R is the multiplier, which is -2. To the n minus 1 power, which n in this case is 15, so the 15 minus 1 power. For me, personally, I just changed that to 14, right? You know, makes it easier. A 15 then is -5 times -2 to the 14th power. It's easier to put it in your calculator than to 15 minus 1. We can do that. So I'm going to go -5 times -2 to the 14th power, right? My calculator, and I get an answer of about -81,920. -81,920 would be the very last term. It gets big. It's exponential, right? We know things exponentially grow and grow. Remember that problem we talked about where you're going to go home and start with 1 penny? And by the 30th day, your parents are going to pay you like $10 million to clean the house, right? Things get big fast when you're talking about anything that's exponential growth, okay? Okay, 12. So what's going on from here to here to here? Now, if you're not sure, seems to me like we're multiplying by a half, but maybe a -1/2. But if you can't see that, if you can't see what the multiplier is, then what you can do is always take, R is always going to equal A2 divided by A1. If you can't see it's -1, I can see it. But if you can't quite figure out what it is, then take my -3/8 divided by 3/4, right? Invert and multiply -3/8 times 4/3 because you're dividing fractions, right? Which sure enough makes a -4/8, or R reduces to -1/2. Okay, but I knew that. But if you can't see it, if you can't see the multiplier, then divide the second one by the first one, and you'll always get the multiplier, okay? So then, let's use our formula. We're going to go A of 12, because we're looking for the 12th term. We're going to use this formula. This is equal to A1, so A1 is 3/4, times R, which is a -1/2, to the n minus 1 power, and n is 12, so it's just 12 minus 1 power, or to the 11th power, right? Now, we can do fractions. I'm probably going to get a decimal answer, but I'll show you what I'm going to do. I'm going to go then 3/4 times -1/2 to the 11th power. You guys right? 11th power, obviously 11 to 12 minus 1. Okay, I'm going to get a decimal probably, and I can change that to a fraction. As a decimal, though, that's a -0.000366. Okay. Scientific notation. Do you see the E? Do you see the E? Do you see E -4? So I'm going to take this decimal and go 1, 2, 3, 4, because that means scientific notation. That E, is that scientific notation? Okay. Yeah, so I thought, there you go, right? Or I can change this into a fraction, which might look better. Nope, it won't give me a fraction anyway, okay? So we'll just go along with that right there, okay? How am I doing? Okay, example 4, I want the 10th term, and I know the 5th, and I know the 7th, but I don't know the 10th, okay? So it's going to look something like this. I've got my 96th.
Can't see it.
Oh, thanks, Katie. I like to do it this way. It's helpful. I'm going to go 96. That's my 5th. That's A5. That's the 5th term. 6th. 7th, right? And I know the 7th is 384. Okay. Now the question is, what's the multiplier? Okay. So if we're not sure what the multiplier is, we can use our formula. We really can. So to use my formula, I'm going to just for a moment, because my formula says I've got a of n equals a1 r to the n minus 1 power. I need to find my r. I need a1. So what I'm going to do is this. I'm going to call this my first term, which would make this my third term. Does that make sense? I mean, if this is the 5th, it's the first one I see. So I'm going to call this my first term. Then I'll call this my third term. And so I have a of 3. So this would be a of 3. So I'll go 384 equals 96 times r to the 3 minus 1 power. So what I'm doing is I'll call this my third term. I'll wait for a second. I'm going to use a of 3. So this is going to be a of 3 and a of 1. I've got my third term. I've got my first term. And the idea is to find r. So, all right, we'll divide by 96, right? Divide by 96, divide by 96. 384 divided by 96, and I get an answer of 4. Okay, I get 4 equals r squared. Then r's got to be 2, right? So r equals 2, all right? So if r is 2, I can make the next term, but I don't really need the 6th term. What am I looking for? 10th term. So I've got a couple of choices. I've got my 7th. I can actually make this if I want to, or use the formula. Wouldn't be that hard to make, would it? Because I have my 7th, then I have my 8th, 9th, 10th. Okay. For me, if it's a short amount, I just use the calculator and find it. If it's super long, I find a formula. Okay. So I know the multiplier is 2, so let's multiply this by 2, right? So 384 times 2, and I get 768. That's my 5th, 6th, 7th, 8th. That's my 8th term. Times that by 2, and I get 1536. 1,536 is my 9th. And if I'm looking for my 10th, I'll just multiply that times 2, and I get 3,072. Okay, that's my 10th term. And again, I could use a formula to get that, but if it's small, I just multiply it out. If it's super big, if I find the 30th, I would find a formula, right? Because a lot of it's just common sense. Okay, example 5. Yep. Geometric mean. Okay. Here's how you find a geometric mean. A geometric mean is equal to the square root of a times b. That's all it is. Geometric mean is just equal to the square root of a times b. All right? It's like an average. So in this case, our geometric mean is equal to the square root of 1/2 times 132. Okay? It's easy, actually. It's just multiply them together and take the square root. This is equal to the square root of 1/64, which is equal to 1/8. That was easy.
No, it wasn't.
So a geometric mean, you just multiply the two numbers and take the square root of their sum. So I multiplied the two numbers. I got 1/64. And I know the square root of 1 is 1 and the square root of 64 is 8. That's how I got my 1/8. Tell me when you're ready to turn the page.
No.
Tell me, I will always wait for you.
What's the test numbers?
Kind of hoping Thursday.
Okay, I'm ready.
Okay?
When will this be
Huh?
When will this be uploaded?
Probably by lunch. Hopefully by the end of this period. Okay. All right, turn the page. Okay, now, the sum. Okay. So the sum of a geometric series, here it is. And we've looked at this one before. We've seen this formula. Okay. Thanks, Katie. So if we were to go back, girls, if we were to go back and add these up instead of list them, we'd get a sum, right? Or if we were to add these up, we'd get a sum, right? So we want to do the same thing. In this case, we want to add them all up, so we should get a single answer, right? And sometimes the sums are pretty big, but we need a formula. So our formula is just S for sum, S of, in this case, 12. S of 12, because we want 12 terms. A1, 1 minus R. Now we need to know the multiplier to the nth term, all divided by 1 minus R. So in your calculator, make sure you use your parentheses. Parentheses are really important in your calculator. Otherwise, you're going to get the wrong answer. So let's take a look at example 6. Okay, so we're going to say S of 12, because we need the sum of the first 12 terms, right? It's equal to A1, which we know is 3, 1 minus. Now, what is R? What's the multiplier?
I don't know, that's a good question.
What do you think is going on from here to here, and from here to here, and from here to here? Now, if you don't know, R is always equal to A2 divided by A1. So if you can't see it, you can find it, right? So it'd have to be a negative 6 divided by 3, which is a negative 2, okay? Sorry, Katie, I'll put that in there. Okay, so if you don't know the multiplier, if you can't see the multiplier, you can't recognize it's negative 2, that's okay. Just take the second one divided by the first one and you get it. Okay, so we're going to go 1 minus negative 2 to the 12th power divided by 1 minus negative 2, okay? I'll let you write that down. Now, be careful of this darn negative. That's why I use parentheses here. I want to make sure the negative is done to the 12th power. I want the negative 2, the whole negative 2 to the 12th power. So I've got to be careful with my parentheses. So in my calculator, I can do this in my calculator. I just have to be careful how I put it in, all right? So clear. I'm going to go 3 parentheses, 1 minus parentheses, negative 2 parentheses to the 12th power parentheses. Okay? There's my 3 times my 1, subtract, negative 2 to the 12th power, close the parentheses, then divided by parentheses, we're going to go 1 minus a negative 2. Now I might put that in parentheses also. Parentheses, okay? Negative 4,095. Did you get negative 4,095? Good, then we're doing it right, okay? So we get negative 4,095. It's the sum of those first 12 terms, okay? Now, David, you asked a great question in the warm-up. You did. You said, well, am I supposed to add them all up? And that symbol means, yeah, add them all up. So we know when we get done, we're going to have 12 terms, and we're going to add them all up. Because that symbol means add them all up, right? So it is geometric. In fact, one of the reasons I know it's geometric is it fits the geometric formula perfectly, doesn't it? See, it fits the geometric formula perfectly. So we know a couple of things. I know A1 is 48. I know R is 1.5, okay? I know that just by looking at it. And you can make a few terms if you don't believe me. And you can see that it's multiplied by 1.5, 1.5 all the way through, okay? Now, what do? We need the sum, right? So we use our S of 12, right? Equals our A1. So I'm using this formula up there, right? We use that formula right there. S of 12 is equal to A1, which is 48, times 1 minus R, and our multiplier is 1.5 to the 12th power divided by parentheses 1 minus 1.5, okay? And I'm just going to use my calculator, put them in, 48 times parentheses 1 minus 1.5 to the power of 12, close parentheses, divided by 1 minus 1.5. And I can answer about 12,359 12,359 and 64844. How's that? Now, okay, example 8 can be done just by doing it, but I kind of want to use a formula, okay? So, if you start with 128 players, right? So if I say game 0, game 0. At game 0, you've got 128 players. Okay, bye, Anlin. But first game, game 1, you got to pair them all up, right? You guys agree? So we're gonna do playoffs, right? Single elimination. We got 128 players, right? So we'd have 64 games. That makes sense? So we'd have 64 games. Well, half of them are gonna lose, right? So game 2, right? Game 2 would be 32, right?
It says single elimination until only one player remains.
Right.
Yeah.
Right.
So would it go down by 1?
No, it go by a half because there's
32 of these guys are going to go home. Half these guys are going to win, and the other half are going to lose.
64 games because it's 128.
Right?
What?
The word game looks weird.
So it's dividing by 2 every single time.
Yeah.
Exactly. Yeah. So, okay, if we paired everybody up here, right? And everybody played, somebody's going to lose, 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 right? The losers leave. Half our classroom would leave, right?
I don't know, man. I'm pretty uncoordinated.
Right? And then we play again. Somebody loses, somebody loses, somebody loses, and half our kids are gone. So game 3 should have 16, right? Game 4 should have 8 players left. Game 5 should have 4 players left. Game 6 should have 2 players left. And then you play a 7th game, you'd have 1 player left, right? And there's your winner. So, in this case, I don't know if I'd even use a formula because it says how many total games we played? Well, 64 plus 32. So it'd be basically 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 game. So we add them all up and we should get it, shouldn't we? Total number of games. Or I could use a formula. Probably in this case it'd be easier just to add them up. Do you agree with me? I'm just going to add them all up. Okay, so almost done. 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, 127 games.
Wait, do you add up the ones we need as well?
No, and I'll tell you why. Let me stop the recording for a second. You don't, because these are players, not games. Okay?
Okay.
So this is not a game. We put 128 players together to play. We'll have 64 games. Does that make sense? Because you pair all these guys up. So you'd have 64 games with 128 players. Okay? You're making it too hard. I know you are. Let me give the homework and then I'll let you think about it. Okay? All right. So homework today. Let me figure out what I wanted to give. And homework today, 12:04. I know, I got to make sure it is recording so I can put the homework on there, okay? Homework today, squeeze it in here. Homework. We are going to go to page 895. And how about we do this? How about we do 5?
Oh my gosh, shut up.
We'll do 9, 12, 14, We'll do 16, 16 and 17. 1, 2, 3, 4, 5 problems. Oh, maybe 18. 8 problems.
Oh, maybe
Eight.
it's
5.
6 problems. There we go.
That's
Okay.
okay.